Hello students, now let us see the resistance and the meaning of the resistance, try to understand, and we'll do some problem based on it. So how do you describe the electrical resistance? This is the questions. So when you talk about the electrical resistance, students, they are saying that resistance is the electrical quantity that measures how the device or material reduce the electric current flow through it. Okay, so anything, it is it is a quantity, you can write quantity which reduce the, what it will reduce, which reduce the flow of, which reduce the flow of what, which reduce the flow of electric current. Okay, so anything which reduce the flow of electric current is known as what, student? Electrical resistance, represented by capital R. The resistance is measured in unit ohm. Okay, what is the unit of resistance, student? That is, unit of resistance is ohm. That is the very important. Okay, now what they are saying, if we make an analogy to water, flow is pipes, the resistance is bigger when the pipe is thinner, so the water flow is decreased. So what is the resistance, students? Resistance, that is anything which reduce the flow of electricity, is known as what, student? Is known as resistance. Now let us see the derivation, student. How can we derive the resistance? So resistance is proportional to length. Okay, resistance is proportional to length, and length of wire, length of wire, you can say that is, student, that is length of wire. Okay, and that is second point, what is resistance is inversely proportional to area of cross section. So that is area of cross section of what, cross section of wire, area of cross section of wire, right, students? Now that is, what is the A is equal to, that is pi r square, that is area of cross section. Combine this 1 and 2 equation, student. If you combine equation 1 and 2, so that is 1 by L upon A, 1 ratio L upon A will come, this will come, R proportional to L by A. If you are remove the proportionality constant, it will come R equal to rho L by A, or no, rho is equal to R A by L. This, what is meaning of the rho, student? R is resistance, L is length, A is area of cross section. If you talk about rho, student, rho, this is the rho. Okay, so rho is known as resistivity. Rho is known as resistivity. Now let us go, students. If you talk about the, what are the other things, resistance is equal to resistivity into L by A, that is what R is equal to, that is rho L by A. This is the concept of the resistance, where R is resistance in ohm, rho is the material resistivity of ohm per meter, conductor, no, L is the conductor length in meter, and cross section area in square meter. So this was the point. What are the factor on which that is resistance depends, students? So that is, you know the relation, you already know, that is R is equal to rho L by A. So that is R is the proportional to L, R is proportional to L. So greater the length, greater with the resistance, the length of no, the length L of the material. Okay, longer the material have, greater the resistance. When 1 meter length is there, resistance is 1 ohm, but 2 meter length is there, resistance is 2 ohm. Now next point, what they are saying is, student, the cross section area of material, larger the area of cross section, lesser the resistance. So suppose 2 ohm resistance is there, when it is the A, one A area of cross section, but if area of cross section is 2 ohm, so it is the 1 ohm. So that is what is there, student. Area of cross section, when you are talking, R inversely proportional to A. So if A is more, R is less, A is more, R is less. So that is what they are saying, the cross section area A of material, larger area, less resistance, right? Next, the temperature T of material, the higher the temperature, usually Result is the higher the resistance. More the temperature, more the resistance. Fourth point, the kind of material. Iron has more electrical resistance of geometrically similar copper conductor. So that is, it is also depending on the different type of material. Now let us move the another point, student. What is the other point slides are there? Why resistance needed? Why the question is there, student? Why resistance needed? Why resistance needed? So let us read out the point, student, if you want to understand. The resistance causes some of the electrical energy. Resistance causes some of the electrical energy to turn into heat. So some electrical energy is lost along the way. Okay, resistance causes some of electrical energy to turn into heat. So some electrical energy is lost. So when it will be heat will generate, means some electrical energy will lost. Therefore, it is sometimes useful to add component called resistor into a electrical circuit to resist the flow of electricity and protect the component in the circuit, right? So that is what resistance causes the student heat to the wires. Next question is there, resistivity. So what is resistivity, student? Already I explained, R is equal to rho L by A. So that is already, rho is the resistivity, that about that. So you can read out the slide, student. The resistance of a conductor is directly proportional to length. Thus, doubling the length will double the resistance, while the having the length would have the resistance, its resistance. Also, resistance of the conductor is inversely proportional to its area of cross section. So, resistivity, if you are calculating, student, resistivity, so rho is equal to, the result is R L by R A by L. So resistivity is equal to R A by L. So this is one more question is high resistance good or bad? Is high resistance good or bad? So let us try to read out the this student. Low resistance, for example 1 ohm, is R is equal to rho L by A. So what is the meaning of this? If R is less, okay, less implies that circuit is good conductor made from materials such as copper, aluminum and carbon, while the high resistance 1 MQ or more implies that circuit is bad conductor made from the insulating materials such glass, porcelain and plastic. So that is the high resistance is bad. High resistance is bad. High resistance is bad. So that is what. Next one, does the resistivity increase with the temperature? Does higher resistance means more heat? High resistance produces more heat. The time t for which current flow, the longer the time, the longer the amount of heat produced. The higher the current, the larger the amount of heat generated. Okay. Next point, why does the resistance decreases as the temperature increases? Okay, so why does the temperature resistance decrease? The more these atom and molecule bounced around, the harder is the electrons to get by. Thus the resistance generally increase with increase in temperature. In some material like silicon, temperature coefficient is resistivity. Coefficient of resistivity is negative, meaning the resistance goes down, temperature increases. So these were the answers, student. What is the relation between temperature and resistance? Okay, so how in a material where the resistance increases with increase in temperature, the material is said to have a positive temperature coefficient. When the resistance fall with the increase in temperature, the material is said to have the negative temperature coefficient. Okay, so these were all about the resistance, students, and thank you so much for watching.